All right, now we are on number 15. We have moved on to transformations. Okay, so describe the transformation of f represented by g. So they give us the original function f here, and they want us to identify the transformations from f to g, which first I see that negative, which is a reflection over the x-axis. And then I see the next difference is the plus 4, which moves it left 4. All right, then for number 16, I notice this 1/2, which is a vertical shrink. The next thing I notice is the plus 4, which again moves it left 4. And then I see the minus 3 outside moves it down 3. Remember, inside is left and right, outside is up and down. Write a rule for G that represents the indicated transformation of F. So first they tell us vertical stretch by 3. So we need to multiply the entire function by 3, and we get 3x to the 4th plus 6x plus 18. Okay, and then followed by translation down 4. So we just simply subtract 4. And our final answer here is 3x to the 4th plus 6x plus 14, because I got 18 minus 4. All right. Same thing, vertical shrink by 1/3. So I'm going to multiply this whole thing by 1/3. And I get 1/3 x to the 4th plus 2/3 x. And then 1/3 of 6 is 2. Now I am translating 2 units left. So that means I have to go inside. And 2 units left would be plus 2. So I'm going to write that right here. So wherever I see an x, I need to replace that with an x plus 2. Okay, so what I did there, I did x plus 2. All right, 19, factor each of the following. We see the first one is a difference of 2 cubes. We can rewrite 8x cubed as 2x cubed. Whoa. Minus 3 cubed. I pull one of each out. And then I remember square, multiply and change the signs, square. So I'm going to square my 2x to get 4x squared. I'm multiplying 2x times negative 3, which would give me negative 6x, but then I need to change the sign. So I have plus 6x, and then I'm squaring my negative 3 to get plus 9. All right, again, I would try to factor this if it did, but it doesn't factor any further. For number 20, we see the same thing, another sum, this time of 2 cubes. 125 can be rewritten as 5x cubed, and then 1 is just 1x cubed, or 1 cubed, excuse me. So I'm going to pull out a 5x and a 1. Then I'm going to square to get 25x squared. Oop. Multiply and change the signs, so negative 5x, and then square my last term plus 1. For number 21, first I see that there's a factor in common. Both of these are divisible by 3, so I'm going to pull that out first. Then I'm left with 8x cubed minus 27. Now I notice that 8x cubed is the same as 2x cubed. And then 27 we know is 3 cubed. I'm going to pull one of each of those out. Don't forget to bring our 3 down on each step. So I have 2x minus 3 here. And then I need to, again, square that first term, 4x squared, multiply, and change the sign. So I get negative 6x, but that turns into a plus 6x. And then square that second term, plus 9. All right, and that is my final answer there. Number 22. My first thing would be, I see x to the 4th and I see 3 terms, so I'm going to try and split this up and factor it as if it were a quadratic. My factors of 12 are 1 and 12, 2 and 6, and 3 and 4. I'm going to start with 3 and 4. Anyway, with 3 and 4, I can get to negative 1. Yes, because I have 3x and 4x here. So if I have a negative 4 plus 3, that gives me my negative, oh, this should be squared, negative x squared. Perfect. Same concept here. I'm going to split this up as x squared and x squared. I'm going to use 3 and 3. And I'd have 3x squared and 3x squared. No way can I add those to get to negative 10. So 3 and 3 didn't work. So my only other option would be 9 and 1. And I know 9 plus 1 gets me 10, so that's hopeful. So I have 9x squared and 1x squared. And I need to get to negative 10. So what I would do is I need to subtract both of those. Uh, 24, again, same idea, split it up as x squared and x squared. And what are my factors of 32? Well, I have 1 and 32. I have 2 and 16. And I have 4 and 8. Okay, so I would typically start with 4 and 8, but I know that there's no way 4 and 8 can add to get to 14. So I'm going to start with 2 and 16. Because I know if I have negative 16 and add 2, that gives me negative 14. And go ahead and check it using this method. All right, on number 25, I instantly notice the x cubed is in common, so I'm going to pull that out, x cubed. And I'm left with x squared minus 9. And here I notice a difference of 2 squares. So I can split this up as x and x, and I need to multiply to get 9, and I need to get rid of my middle term, so I'm going to make them conjugates. All right, here I see the 4 and the x in common, and I'm left with x squared minus 1. Again, I see a difference of 2 squares here, so I'm going to split it up x and x, 1 and 1. 1 needs to be positive, and 1 needs to be negative. Again, take out what's in common, which is the x, and I'm left with x squared minus 16. I know 16 is a perfect square, so this is going to factor as a difference of 2 squares. But once again, which is 4 and 4, and I need negative, so they need to be opposite signs, conjugates. All right, number 28. Write a polynomial function f in standard form of least degree that has rational coefficients, a leading coefficient of 1, and the given zeros. So all right, so I'm going to write these as factors. So I have x minus 1, x minus 3, and x plus 6. And then what do I need to do? I need to multiply those out. Distribute my x, I get x squared minus 3x minus x plus 3. And I'm going to clean that up to get x squared minus 4x plus 3. And then I'm going to multiply that by x plus 6. Don't forget about that. All right, so I need to distribute my x's to every term. And then as well as my 6. Get plus 6x squared minus 24x plus 18. And then when I clean all that up, I get x cubed plus 2x squared minus 21x plus 18. All right, 29 is where we kind of start to run into some difficulties. I want to write this as x minus 3. But remember, if we have a factor of x minus I, we also have x plus I. Okay, so I have x minus 5 minus I, but I also have x minus 5 plus I. All right, so I'm going to start by factoring these two, and we first want to do some regrouping. So I want to group together my x minus 5. Because then when I FOIL this, I get x minus 5 squared. And then notice these are conjugates, so all of our middle terms are going to cancel, but I'll write those out so you can see that. We get x minus 5. And we get negative x minus 5i. And then my negative I times I is negative I squared. Okay, so when I clean this up, these two cancel. And remember, I squared equals negative 1. So I have negative negative 1, which gives me plus 1. So if I rewrite this, I have x minus 3 times x minus 5 squared plus 1. Okay, now I need to FOIL my x minus 5 squared, which is x squared minus 10x plus 25. And then I need to add my 1, which gives me 26. Okay, now one last distribution here, multiplication of polynomials. And I get x cubed minus 10x squared plus 26x minus 3x squared plus 30x plus 78, I believe. 3 times 26 is 78. Actually, that's going to be a minus. So we have a negative 3. Okay, combine our like terms. I only have 1x cubed, so it's x cubed minus 13x squared plus 56x minus 78. All right, now number 30. I'm going to go ahead and write 30 down here because it's going to be a really long problem. So we have our zeros are negative 2, 3 plus 2i, and square root of 5. Now, whenever we see the 3 plus 2i, we also know that 3 minus 2i is a root, and as well as negative square root of 5. Okay. I'm going to write all these as factors. So I have x plus 2, x minus 3 plus 2i, x minus 3 minus 2i, x minus the square root of 5, and x, it would be minus the square root of 5. So I'm just going to write that as plus. All right, so I'm going to start right here by regrouping. So instead of rewriting the whole thing, I'm just going to write it in red. Regrouping there, and then since they're conjugates, I'm not going to bother with those middle terms. So I'm going to square the first term and square, and then multiply the last term. So I get x minus 3 squared, and then 2i times negative 2i gives me negative 4i squared. And the reason I can do that is because they're conjugates. All right, same idea here with the x minus the square root of 5. So I'm going to multiply the first two, which gives me x squared, and then negative square root of 5 times the square root of 5 gives me negative the square root of 25. And all of this, don't forget, is multiplied by the x plus 2. Okay, so I have x plus 2, and I'm going to FOIL this to get x squared minus 6x plus 9. And then that is minus, remember, I squared equals negative 1. So negative 4 times negative 1 gives me plus 4. And then x squared minus 25 is x squared minus 5. All right, one more simplification here. 9 plus 4 is 13. Okay, now I'm going to multiply these first two. I get x cubed minus 6x squared plus 13x plus 2x squared minus 12x plus 26. And that's all multiplied by x squared minus 5. Okay, now I combine my like terms, and I get x cubed minus 4x squared plus x plus 26 multiplied by x squared minus 5. Okay, one last distribution here. I need to multiply my x squared by everything to get, I get x to the 5th minus 4x to the 4th plus x to the 3rd plus 26x squared. And then multiply my 5 by everything. Negative 5x cubed minus plus 20x squared minus 5x minus 130. Now we need to combine all our like terms to get x to the 5th minus 4x to the 4th minus 4x cubed plus 46x squared minus 5x minus 130. Whoop. All right, so I know that was a lot of work, but persistence is key and it pays off. Okay, so now let's go back up to number 31. Decide if the polynomial is a function. Remember here we have two rules for a polynomial to be functions. All of the exponents need to be whole numbers, and all of the coefficients need to be real numbers. In this case, both are true, so yes, this is. And then for something to be in standard form, we write it with the highest power first. So 4x to the 4th minus 2x cubed plus 1/2 x. I know my degree is 4, which makes it quartic. and my leading coefficient is 4 or positive. All right, 32, are all of my exponents whole numbers? No, they're not, because this -1, so this is not a polynomial. All right, last section here. Number 33, we're looking for the degree. Two ways I can analyze this. See, I look at my x-intercepts. Here I know there's a repeated, so from there I can find that it's 3, or looking at the function, I see my highest power is x to the third. Leading coefficient is 1, or positive. My zeros are, I'm going to use the graph right here. I know there's 2 zeros at x equals -3, and it goes through at 1. Right, so those are my zeros. Number of turning points is 2, right? There's one here and one here. My y-intercept looks to be -10, so I'm 0, -10. What's the domain of this function? What x values does it cover, or how far left or right does it go? -infinity to infinity. My range, also -infinity to infinity, because it goes up and down forever. The type of function, so this would be, it's third degree, so it's cubic. Intervals of increasing. So again, if I were to trace this with my pencil, it's increasing right here as well as right here. So they are -infinity to -3. And then don't forget, when we have 2, we need to connect them with a union symbol. And then my second is -1 to infinity. Where is it decreasing? Just the opposite right here, which is -3 to -1. Remember, I'm using parentheses because it's neither increasing nor decreasing at that exact point. Now I'm looking for my local max, which would be right here. It is 0, -3. Where's my local min? Let's see, right here, -1, 0, and I actually wrote this backwards. This should be -3, 0. Where is f of x greater than 0? So that's right here, right? Which would be from 1 to infinity. Again, we're using x values for that. Super important, x values for that. Where is it less than 0? This is where we have to be kind of careful, because notice here it's equal to 0 and here it's equal to 0. So we're going to have two intervals there. So from -infinity to -3, and from -3 to 1. We have to split this into two intervals because we can't include -3, because at -3 it's equal to 0. As f of x goes to -infinity, as it moves further to the left, my graph is going to -infinity. As it moves to the right, the graph is going to positive infinity. Last one, 34. The degree of this function is 4. I found that from right here. My leading coefficient is 1. My zeros are x equals -2, -2, 1, and 1. I found that from the graph. Number of turning points, 1, 2, 3. Remember, that's always going to be 1 less than the degree. My y-intercept looks to be 1, 2, 3, 4. So 0, 4. The domain, -infinity to infinity, that should be automatic. My range, what's the lowest this graph touches? 0, and it goes to infinity. This is a 4th degree polynomial, so it's quartic. My intervals of increasing, where's my graph increasing? Well, right here, as well as right there. So from -2 to, this looks to be about 1/2. And union 1 to infinity. Where is my graph decreasing? That would be right here and right here. So from negative infinity to negative 2, as well as 1/2, that was to 1. Local max right here, which we decided that was 1/2, so we're going to say negative 1/2, 0. And yes, these should be negative, sorry. Negative 1/2 there and negative 1/2 there. Sorry about that. Local mins right here. They are at negative 2, 0, and 1, 0. Whereas f of x greater than 0, again, that's anywhere above the x-axis, but be careful, we're going to have to split this into 3 intervals because it touches twice. So from negative infinity to negative 2, negative 2 to 1, and 1 to infinity. Again, we can't include the 0.10 or negative 20 because that's where it's equal to 0. Where is f of x less than 0? So below the x-axis. If you put never or none, not at all, it doesn't ever drop below the x-axis. Now, as f of x goes to negative infinity, my graph is going up to infinity. And as x goes to infinity, my graph again is going up to infinity. That is the end of the review. If you have any questions, please reach out. And don't forget to take your test on Friday, December 18th. Again, if you have a bunch of tests on Friday, please reach out to Miss Bowling, Miss Nelson, or Miss Schmitz, whoever your teacher is, to set up some accommodations for that. Have a great day.